All right, so again, remember, the cube root of what number is 2? 8, because 2, this is 2 right here, right? Because 2 times 2 times 2 is what? 8. So you could have done that by inspection. But we saw last time that it's not going to be that easy. So how do you want to approach this equation? What did you remember last time? You cube both sides. Because what's the index? Index is 3. So if I want to get rid of the cube root and get x by itself, I've got to do the inverse operation. So the inverse operation of taking the cube root is to raise both sides to the third power. All right, and so then the cube root and the cube undo each other, and so on the left side, what do you have?
X equals
X, and 2 times itself 3 times is 8. All right, so the cube root of 8 is 2. But it's not always going to be that simple. You know, that's the simplest kind you can have. So we need to look at some examples that involves a little bit more algebra in it. So let's look at number 2. And for us, we're going to be more interested in square roots. Now remember that's 3, and you can't see very well because of the projector. Usually, no matter what room you're in, the RCC has the worst projector possible. But the index is what up there? 3. That's the index. All right, now, listen carefully to this one. Suppose I want to solve this equation. The square root of 5x minus 1 equal 8. Now, you may need to calculate for some of you. So the square root of 5x minus 1 equal 8. All right, so on that handout I gave you, there are some steps there on this handout. And so step number 1 says to do what? Isolate the radical expression on one side of the equation. Now for us today, the radicals, there will only be one radical expression. All right, so in this case, where's the radical expression located? On the left, and is it by itself?
Yeah.
Yes. All right, so step 1's already been done for you. All right, now remember what we did with number 1. So if I want to get rid of the radical symbol, I've got to raise both sides to a power equal to the, what's that word? Index. So in number 2, what is the index? 2. Now, remember, I think last time, a couple of you maybe said 1. There's no 1 root. The smallest index is what? 2. So if it's not there, it's understood to be a 2. So that's square root. Okay, so we're on step 2. So I'm going to go ahead and rewrite this over. And remember, when you do the worksheets, make sure you show the steps. Don't leave anything mathematically incorrect. So if you do and your answer is correct, you probably won't get full credit, but that's okay. You use that to remind yourself, oh, he took points away, so I got to remember on the test not to do that same thing. That's the whole point of these worksheets, preparing for the test. All right, what's the next step? Step 2, what do I need to do?
Square both sides.
Square both sides. So I'm going to square both sides. Just like this. What you do to one side, you do to the other. Okay? And by raising both sides to a power equal to the index, you are able to remove that radical expression. So the square and the square root undo each other just like this. They're inverse operations. So you're left with the radicand. What's my radicand?
5x minus 1.
Equal?
64.
64. And so notice I went from a radical equation to what kind of equation?
Linear.
Linear. So you just solve the linear equation. All right, so when solving a linear equation, you want to get the variable by itself. So what's the next step?
Add 1.
Yeah, and you can you're in college algebra now. You're no longer in 99 or 98 or 97, whatever it may be. So if you want to skip a step, you can. So you can say 5x equal what? 65. But keep in mind what's happening is that you're really adding 1 to both sides, right? So you're using what property? What property they just used? Do you remember what that's called? The addition property of equality. the addition property of equality. So 5x equals 65. And again, you can just use your calculator and just say x equals the solution. But basically what's happening is that to get x by itself, what do you need to do to both sides? Divide both sides by the coefficient, and the coefficient of x is 5. And so 5 divided by 5 is 1. And so what does x equal? 13? All right. Now you're going to see, if you notice, the title of that handout I gave you is Radical Equations with Extraneous Solutions. So there are going to be situations where you're going to end up with extraneous solutions, and we're going to talk about that, what that means when we get to a problem like that. But to be on the safe side, what you need to do at this point when solving a radical equation, and really all you got to do is just, whenever you raise it an even power, which we will because we're dealing with what kind of radicals here? Square roots. And so you're going to raise both sides to what power? The second, which is an even number, right?
Yes.
Okay, so you're going to have to check. So remember, you must check your solutions. Must check your solutions. So when we solved the quadratic equations, we didn't have to check solutions. If I did all the mathematics correctly, I was good. But when you're doing a radical equation, which you're raising both sides to an even power, you need to check your solutions. It's only to the even power. So let's go back and check. All right, so you go back to the original. Always go back to the original. So here's my original equation. And so wherever I see the variable x, what do I substitute? 13. All right, so I'm going to get the square root of 5 times 13 minus 1, and I want to see if that's going to equal to 8. And so you just use your calculator and you figure out the radicand. What's 5 times 13?
65.
All right, and then what's 65 minus 1? All right, now I'm going to ask you this. Is the square root of 64 equal to 8?
Yep.
Yeah. So 13 is a solution. 13 is not an extraneous solution. You still don't know what an extraneous solution is. We'll get to that word again when we get to a problem that has some. All right, number 3. Let's suppose I had this. So you have the square root of x minus 3 plus 2 equal 7. Square root of 6x. I keep saying 6x, the next one is 6x. So the square root of x minus 3 plus 2 equals 7. All right, so what's the first thing I got to do?
Subtract 2.
Say again?
Subtract 2.
Yeah, so you got to isolate the radical, right? So the square root's not by itself. What's on the same side with it? What term's on the same side with the square root? 2, the constant. So we got to subtract 2 from both sides. So when I subtract 2 from both sides, I'm going to get the square root of x minus 3 equal 5. All right, now let's do the mathematics. Step 2. Step 2 says I have to do what to both sides? Square both sides. So I'm going to square both sides. And then the square root and the square undo each other. So I get x minus 3 equal,
14.
oh, not 14.
Oh, 49.
5 times 5 is 25.
I'm looking at
All right, and then finally, what's my solution? What does x equal?
28.
28?
Yeah.
All right, again, since I raised both sides to an even power, I may have introduced extraneous solutions. And extraneous for us means false. So solutions that are solutions to this linear, but not a solution to the original. And again, we'll talk more about that in a little while. All right, so let's see if this works. Always go back to the original. So let's check the original. The square root of x minus 3 plus 2 equals 7. So I want to see if the left side is going to equal 7. Well, x is 28, so I have the square root of 28 minus 3 plus 2, and again, I want to see that's going to equal 7. So notice I just put a little question mark above the equal sign. This little question mark above the equal sign. What is 28 minus 3?
25.
25. And what's the square root of 25? And is 5 plus 2 equal to 7?
Yeah.
Yeah. All right, so x equal 28 is a solution. All right, now let's look at number 4. All right, number 4. You have the square root of 6x plus 7 equals x. The square root of 6x plus 7 equals x. All right. Is step 1 already done for you?
Yep.
Yeah, it's already done for you. So step 2 says I have to do what to both sides? Square both sides. All right, so you square both sides. All right, just like that. And then I'm going to simplify what I can. Then on the left side, the square and the square root undo each other, so what's left? On the left side,
6x plus 7.
6x plus 7 equal x squared. All right, so I no longer have the radical. Now when I did 2 and 3, if I just look at 2 and 3 for right now, when I square both sides and I did the inverse operation, I was left with what kind of equation right here?
Linear.
And I was left with what kind of equation right here?
Linear.
Linear as well. But in this case, I have what kind of equation?
Quadratic.
Quadratic. All right, so you have to remember how to solve a quadratic equation. Now, for us, when you square both sides, the quadratic equation that's left will be factorable. So let's go ahead and factor this. It doesn't have to be, but the ones that we have will be factorable. Okay, so how do you first of all, if I'm going to factor this quadratic equation, what's the first thing I've got to do? I'm going to do a quiz today. It's got to be in what form? Standard form. All right, and always make sure that the x squared coefficient is positive. So since x squared, the coefficient of x squared is positive here, let's just bring everything to the other side. Now some of you still have an issue of determining, well, if I bring the 6x over, does the sign change? Well, that you should already know because look, if I have a 6x plus 7 here and I want to get rid of that plus 7, what's the opposite? Subtract 7. So you subtract 7 from both sides, right?
Yeah.
And so basically using the addition property of equality, so you get 6x equal x squared minus 7. Then what's the next step?
6x.
Subtract 6x from both sides. And let's go ahead and put this in descending order. Now what's 6x minus 6x? 0. So I get x squared, descending order, minus 6x, minus 7. So I use the word descending order. You may remember that. So descending order is where you go from the largest exponent. You write the term that has the largest exponent first, and then the next one, and so on. So your constant is always listed last. So do y'all agree that this right here is this? And I'm going to go ahead and put the x squared minus 6x minus 7, the trinomial, on the other side. So do y'all agree, first of all, do y'all agree that this statement, that 6 equals 12 over 2 is the same thing as saying 12 over 2 equals 6? Yes or no?
Yeah.
Yes. So left equals right means the same thing as right equals left. So it is mathematically correct to say that this right here is the same thing as saying x squared minus 6x minus 7 equal 0. All right, so it's factorable. Now you don't have to factor. You can use quadratic formula. Nothing wrong with using quadratic formula, but it is factorable. So let's go ahead and factor the two binomials. Now remember, just don't put the two binomials in and forget about the equal 0, because this is an equation, so you must still have an equation at each step. So you must say equals 0, okay? All right, what do you think the factors are?
X times X, and then 7 and 1.
7 and 1, okay? The last sign's negative. That means these signs in here are
Opposite.
different. So which one's which?
7 is minus.
Okay, so x minus 7 times x plus 1. And you can always check by filling this out to make sure you get the original back. All right, so x squared minus 6x minus 7 is factored as x minus 7 times x plus 1. Now, what's the next step I do?
Set each term equal to 0.
So remember, you got to solve this. So you got to set each one equal to 0. What property am I using when I do that? The zero factor property. Zero factor property. So I said each one equal to 0. X minus 7 equals 0. X plus 1 equals 0. Okay? And so notice I went from a quadratic equation, a radical equation, to a quadratic equation to two linear equations. So let's solve the linear equation. So what's x over here? And what's x over here? Negative 1. All right. So those are solutions to that quadratic definitely, right? Okay? Yes.
What if we moved the x squared and we had an x squared and we had to factor out negative 1? Would that be,
What now?
if we moved everything to the left side instead of to the right, and our
Okay.
leading factor was a negative?
Multiply everything by negative 1. You want to make it positive. It's easy to factor if the coefficient of x squared is positive.
Yeah, that's what I did, but when you get to the last part, when you break everything apart, what happens to that negative 1 then? Like after you
I'm
factor it out?
confused as to, you're talking about this right here? What are you talking about? You're talking about this right here?
Go down the steps. So if my x squared was negative.
Okay, you're going back to this now. You're saying your x squared is negative. The x squared here is a positive 1. Well,
I know what I'm saying is, what if I move the x squared to the left side?
Okay, so if you move the x squared to the left side, no big deal. I get 6x plus 7 minus x squared. Y'all agree with that? Okay, but remember, we made the statement that it is a lot easier to factor if the coefficient of x squared is positive. Well, she wrote it like this, it's not positive, right? Well, remember, what you do one side, you do the other. So if you multiply the left side by negative 1, I multiply the right side by negative 1. So you just multiply everything by negative 1. So when you multiply by negative 1, and distribute, I get negative 6x minus 7 plus x squared equals 0. And if you put it in descending order, is that this right here? Can't see it, but is that? Yeah. Okay, I'm not sure why you want x squared to be negative, but if you do want it, let's talk after class so I can make sure you're doing it correct, okay? But that's what you do. If you bring the x squared to the other side and the coefficient is negative, just multiply everything by negative 1. What you do one side, you do the other. Okay, so let's talk about now. Remember, I started out with what kind of equation? Radical. I didn't start with a quadratic. I started out with a radical equation, and I raised both sides to what power? An even power, though, right? An even power. So you must check the original. You must check. So let's check the 7 first. Let's check the 7 first. All right, so we're going to check x equals 7 into the original. So here is the original. All right, so where we see the variable x, I substitute 7. So I get the square root of 6 times 7 plus 7. And I want to see if that's going to equal to x. And again, what's x? 7. All right, so let's work on the left side. What's 6 times 7?
42.
And 42 plus 7?
49.
All right, I'm going to ask you this. Is the square root of 49 equal to a 7? Yes. So 7 is a solution. 7 is a solution to the original equation. And the original equation, what kind of equation? A radical equation. Now let's check -1. All right, check x equal -1. All right, go back to the original again, and the square root of 6x plus 7 equal x. So wherever we see the variable x, what do I substitute? -1. All right, now you got to be careful with that one. You have 6 times a -1 plus 7. And I want to see if that's going to equal x, and what's x? -1. All right, what's 6 times a -1? And what's -6 plus 7? 1. Okay. So that's the square root of 1. Y'all agree? And what's the square root of 1? Is 1 equal to a -1? No. 1 does not equal a -1. So what that means is that in terms of the original equation, the only solution is which one? 7. So x equals 7 is the only solution. X equal -1, let me just tell you what that means. So x equal -1 is a solution to which of these equations I have listed along the process? The quadratic. X equal -1 is a solution. The solution to which equation? The quadratic one, isn't it? Because that's how we got it. But it's not a solution to the original. So whenever you raise both sides to an even power, you potentially introduce false solutions, and we call them extraneous solutions. So x equal -1 is an extraneous solution. So that would be an extraneous solution. It's not a solution to the original. It's a solution to the quadratic. It's also a solution to one of the linear ones, but it's not a solution to the original. So whenever you raise both sides to even power, you must do what? Check. You must check. Okay? And that's easy to forget, by the way, to check. So if you did all that work and you said in the blank x equals 7 and x equal -1, and it was 10 points, you'd probably lose maybe a point or a point and a half. You get most of it, but you just forgot to check. All right. So in the blank, though, what's the only solution you put in the blank? 7. Okay, don't say x equal -1 also, because it's not a solution to the original. It's a solution to this linear equation. It's a solution to this quadratic equation, but it's not a solution to the original. Okay? All right, so that's number 4. So in that handout, you'll see that it says check the proposed solutions for any extraneous solutions. So in number 4, we did have an extraneous root, so I can't use it. All right, let's look at number 5. All right, number 5. You have, all right, now, okay, let's do this one. X equal the square root of 5 minus x minus 1. X equal the square root of 5 minus x minus 1. Now, it looks a little bit more complicated than the others you've had, but follow the steps. What does step 1 tell us to do? No, step 1 does not tell us to square both sides. What does step 1 tell us to do?
Isolate the radical.
Isolate the radical. Is the square root by itself? No, there's a subtract 1 there, right? So what do I need to do to both sides? Add 1 to both sides. So basically you're saying this, plus 1, plus 1. And so on the left side, I get what expression?
1x.
No, be careful. Those are not like terms. So you have to say what?
1 plus x.
1 plus x or
X
x plus 1. Those are not like terms. And on the right side, what's left?
Square root of 5 minus x.
Square root of 5 minus x. So I've isolated the radical. All right. Now compare that one with the previous one. So in the previous one, if you go back, just try and make that connection. When I go back to the previous one, you see how I had isolated the radical here, But on the other side, I had how many terms?
One.
1. So that made it easy for us. On this side, I have how many terms? 2. So there's a little bit more work we have to do. Okay? So you got to be careful with your algebra. Because if you mess up on any of those, then you have errors all over the place. All right, what's the next step? Square both sides. Okay. So I'm going to put, since this is a binomial right here, I'm going to put that in parentheses. So I'm going to say parentheses, x plus 1, all raised to what power? Second. Equal the square root of 5 minus x, all raised to what power? Second. So next up is to square both sides. The right side is easy. What expression is left on the right side? 5 minus x. The square and the square root undo each other. So that's 5 minus x. All right, now let's talk about the other side. You had this in a previous courses, more than one course. How do you multiply x plus 1 squared? Huh? No, it's not x squared plus 1. You got to be careful. See, and that's a mistake people will make. So they'll say, well, x plus 1 squared is x squared plus 1. No, it's not. You've already lost some points right there. And you're not going to find the correct solution. How do you multiply x plus 1 in parentheses squared? X plus 1 in parentheses squared means x plus 1 times itself. And then you use the FOIL method. Okay, so you got to go off to the side and do all that work. So x plus 1 times x plus 1, right? All right, let's do the FOIL method. X times x?
X squared.
What's the outer?
1x. Or plus x.
Okay, and the inner?
1x.
Same thing. So if you're squaring a binomial, you will always remember that the outer and the inner are going to be the same thing. And what's the last?
1.
1 times 1 is 1. Combine like terms, what do I get?
X squared plus 2x plus 1.
Yeah. So if you made the mistake and you said x squared plus 1, you forgot that linear term, that 2x. So you got to be careful. So that goes on the other side. So it's a little bit of work. In between watching TV shows on Netflix, you can do the work. All right, what kind of equation did I end up with?
Quadratic and a linear?
Quadratic. No, quadratic. That's quadratic equation, right? Okay, it's a quadratic equation. How do you solve a quadratic equation?
Factor.
All right, first of all, it's got to be in what form? Standard form. So we're going to get your test today. It's not going to be in standard form. You got your quiz. You got to make sure it's in standard form. So x squared, the coefficient's positive on the other side. So let's just bring the 5x, the 5 and the negative x to the other side. So do y'all agree? I'm going to skip a step here. That I get x squared plus 2x plus 1, and then tell me what the other two terms become.
Squared plus 3x.
Tell me what the other two terms become.
Oh.
Bring the 5 over. What does that become? Minus 5, and then what?
Plus x.
Plus x equal what?
0.
0. Okay. All right, what's the next step? What was that? Combine like terms. Combine like terms. And let's put in descending order. So when I combine like terms, I get x squared. And what's 2x and x?
3x.
3x. And then my constant is?
Negative 4.
Negative 4 equal 0. Okay. All right, so notice we went through, compare number 5 with number 4. It does help to look at a comparison. All right, and then notice I went from a radical equation to what kind of equation?
Quadratic.
And it's in standard form now. And we indicated that you can use quadratic formula or it's factorable for us. So let's just go ahead and factor. All right, what do you get? X minus 1 times x
Plus 4.
plus 4. Okay, that works. X minus 1 times x plus 4. Because if you check it, Remember, always check using a FOIL. X times x is x squared. The outer is 4x. The inner is a negative x. When I add them up, I get the positive 3x.
Mhm.
And the negative 1 times a positive 4 is a negative 4. All right, once you get to that point, what's the next step? Use zero factor property, say each one equal to 0, because one of them has to be 0. That's the only way you can get a product at 0. So x minus 1 equals 0, x plus 4 equals 0. So notice I went from this quadratic equation now to 2 linear. So what's x over here? 1. What's x over here? Negative 4. All right, so let's check our proposed solutions. So those are proposed solutions to the original, because we know that since I raise both sides in even power, the solutions I end up with may not work. They may not be solutions to the original. So those are proposed solutions, but do you understand that those are solutions to something? What are these solutions? So let's talk about the solution x equal 1. That's the solution to this linear, right? It's also a solution to the quadratic, but now we got to see, is it a solution to the original? That's what we have to do. Okay, so let's check x equal 1. All right, so I'll write the original over. Go back to the original. All right, so wherever we see the variable x, I'm going to substitute 1. So I get 1 equal the square root of 5 minus 1 minus 1. All right, what's the next step? Yeah, let's deal with the radicand on the right side. So 5 minus 1 is 4. So the square root of 4 is 2, and is 2 minus 1 equal to this 1?
Yep.
Yeah. So x equal 1 is going to be a solution. Let's check x equal negative 4. So if I go back and I check x equal negative 4, again, you go back to the original. Oops. The original equation. All right, where we see the variable x, what do I substitute? All right, so I have x here, so that's negative 4 equal the square root of 5 minus x, and what's x? Negative 4. Whatever that is, I'm going to subtract 1. Now, some of you still have a little bit of issue with signed numbers. What's 5 minus negative 4? 9. If you couldn't get 9, if you didn't say 9, use your calculator. And the square root of 9 is 3. And what's 3 minus 1? 2. Is 2 equal to a negative 4? No. So x equal negative 4 is not that proposed solution is not a solution. It's actually what kind of solution? Extraneous solution. So it's a false solution. So in the blank, though, what's the only solution to the original? 1. So x equal 1 is the only solution. Okay? All right, let's look at this one. We can do another one. So you should be getting a little bit better with this. All right, good. Just make sure you go back and look at the videos and look at the notes. All right, so this would be number 6. You have the square root of 4 minus 2t minus t squared equal t plus 2. The square root of 4 minus 2t minus t squared equal t plus 2. So what's the first step? What was that? Isolate the radical, okay. Is it already done?
Yep.
Yeah. What's the second step?
Square both sides.
Square both sides. I'm going to go ahead and rewrite this over. Let's go ahead and square both sides. All right. And so when I square both sides, on the left, what expression is left?
1 minus 2t.
minus t squared. So the square and the square root undo each other. All right, now on the other side, I've got to multiply this out. So that's t plus 2 times t plus 2. So I'm going to follow this out. So again, don't make the mistake and say t squared plus 4 because you're missing a term. So when I follow it out, first times first, that's t squared. The outer is 2t. The inner is also 2t. And the last is 4. When I combine like terms, what do I get? Plus 4? All right, so that's this. All right, so that's where I'm at. Okay, so now I went from a radical equation, and what kind of equation is this? Quadratic. So let's go ahead and put it in standard form. Now notice there's a t squared on both sides. So this coefficient t squared is positive, so let's just bring everything to the right-hand side. So if you want to do it in steps, you can. Basically what's happening is this. So you're gonna add t squared to both sides. I'm gonna go ahead and line my like terms. And when I combine like terms, I get 4 minus 2t equal, now what's t squared plus t squared?
2t squared.
2t squared plus 4t plus 4. So just do one thing at a time if you have to. Okay, now let's deal with another term. Let's deal with that negative 2x. So what are we going to do to both sides?
Add to both sides.
Add what to both sides? I said 2x, I meant 2t, that negative 2t. You're going to add what to both sides? 2t. And notice I'm aligning my like terms. You're aligning your like terms, and then combining them. So that's 0. I get 4 equals 2t squared plus 6t plus 4. And then finally I do what? Subtract negative 4 from both sides. And so 4 minus 4 is 0. So I get 0 equal 2t squared plus 6t. So that's where I'm at. Okay. And it's in descending order, it's in standard form. Now you can use quadratic formula, and I'll do both just to show you what to do. Or you can factor. Now, how do you factor that right-hand side? Let's see if you remember something from last semester. Say it again. Okay, so what's the least common multiple? 2t, right?
Mm-hmm.
So remember the GCF, greatest common factor? So the GCF is 2t. So notice it's not trinomial. So you don't do the two binomials. That's not a trinomial. That's a what? Binomial. So the only time you're going to do the two binomials is if you have a trinomial. Okay? All right, so that's a binomial. So one of the things you learned last semester was the idea of a greatest common factor. So if you look at this, y'all agree that's 2t times, and then what do I get? T plus 3. And you can check what's 2t times t?
2t squared.
2t squared. And what's 2t times 3? 6t. All right. And then again, I have this product that's equal to 0. Now the way I would do this is I see this t plus 3? I would underline that, and then I would underline the 2t. And then so I have these two factors that are underlined. So one of them has to be what?
0.
0. So I set them both equal to 0. So when I do that, I get 2t equals 0. And what's the other one?
T plus 3.
T plus 3 equals 0. Well, let's do this one first. If t plus 3 equals 0, what's t?
Negative 3.
Negative 3. If 2t equals 0, how do I get t by itself? Divide by 2. And 0 divided by 2 is 0. So those are my two proposed solutions, 0 and negative 3. Now before we go on, let's do this using a quadratic formula. So if I'm going to do this using a quadratic formula, remember ax squared plus bx plus c equals 0. And so negative b plus or minus the square root of b squared minus 4ac. All of this is being divided by 2 times a. All right, so if I look at this quadratic equation right here, what is a? 2. What is b? 6. What is c? What's my constant? You don't see a constant. So it's understood to be what? 0. So c is 0. So a is 2, b is 6, c is 0. There's no constant there. So make sure you see why c is 0. Because look, if I have this right here, 2t squared plus 6t, do y'all agree that's the same thing as saying 2t squared plus 6t plus 0?
Mm-hmm.
So a is 2, b is 6, and c is what? 0. All right, so you just plug in, and you get the opposite of b. So what's the opposite of b? Negative 6 plus or minus the square root of b, and what's b? And I'm doing what to that? Squaring it? Minus 4 times a, what's a? And what's c? All divided by, now look, some of you are doing this. You're saying all divided by 2a, and what's 2a? What's a? 2. But that's not mathematically correct. What? Oh yeah, but you can write 4. But what's wrong with the way that I wrote this? Not everything is being divided by 4. You got to extend this. So make sure on your quiz that you understand that this whole thing is being divided by 4. So just make a note of that. I don't know if it's because I'm sure you know that. You probably don't need it because you're trying to quickly do the work and you're not being very careful. Okay, so let's look at the right hand. I have negative 6 plus or minus the square root of, what's 6 squared?
36.
What's a negative 4 times 2 times 0?
0.
0, right? Yep. So my discriminant, my radicand, is just what number? 36. All divided by what? 4. All right. Now, what's the square root of 36? 6. Now, remember we talked about rational and irrational. Are my solution going to be rational or irrational? Are my solution going to be rational or irrational? Rational, because when I take this, because 36 is a perfect square, so when I take the square root of 36, the square root is no longer there. So do y'all agree that's going to be negative 6 plus 6 divided by 4? And what's the other?
Negative 6 minus 6.
Divided by 4. What's negative 6 plus 6?
0.
And what's 0 divided by 4?
0.
0. So there's one of your solutions right there. Okay. What's negative 6 and a negative 6? Negative 12 divided by 4, which reduces to negative 3. And there's the other solution. So if you had trouble factoring, then just go ahead and use what? Quadratic formula. It takes a little bit longer, but some of you still have a little bit of issues with factoring as well. So it's a trade-off. All right, now we're not done with the problem. I found my proposed solutions. I got to check to see if any are extraneous. So let's do the 0 first. So let's check. So check t equals 0. All right, t equals 0. So I'll go back to the original. Here was the original. It was the square root of 4 minus 2t minus t squared. And I want to see if that's going to equal to t plus 2. So where we see the variable t, what do you substitute?
0.
0. So I get the square root of 4 minus 2 times 0 minus 0 squared. Okay. And I want to see if that's going to equal 0 plus 2. So wherever I saw the variable t, I substituted 0. What? Wherever I saw the variable t, I substituted 0. So there's 0 in all their places. Now let's look at the radicand. What's 2 times 0? And what's 0 squared? So what's the only the only value, the only number that's under the radical. What do you get? Square root of what? 4. On the other side, what's 0 plus 2? 2. And the question is the square root of 4 equal to 2? Yeah. So t equals 0 is a solution to the radical equation. Now I have to check negative 3. Now, at this point, there's always students that think, well, it looks like every proposed solution that's negative is extraneous, and that's not true. It's just those examples. So in some of the worksheets, if you or my math lab, if you see a negative as a proposed solution, that doesn't necessarily mean it's extraneous. You got to check. Okay, you have to check. All right, so let's check t equal negative 3. All right, so the original problem, which is this, I'm running out of room. So notice it's a lot of work right here, right? Usually the one on a test or a final doesn't involve that much work. But on a worksheet, it will, because you have time to do it. So where we see the variable t, what do you substitute? Negative 3. And that's where some of you are going to probably mess up if you're not careful. So you got to be careful as we go through this. So notice that's the square root of 4 minus 2 times t. What's t? Negative 3. Minus t, I'm putting that in parentheses. And what am I doing to that negative 3? Squaring it. So that's how it looks. Now you can't see it very well because of our projection system. Equal, and then what's t again? No, t is not 3. What's t? So I get negative 3 plus 2. Okay? All right, now let's go under the radical. Now listen carefully. Think of this right here where I have 4 minus 2 times a negative 3. Think of this as a negative 2 times a negative 3. So far I have 4 what? Plus 6. Okay, now be careful with the next one. So you have to remember some things from a previous course. What is being squared? Negative 3. So what's negative 3 times itself? 9. Okay? A negative times a negative is a positive. So do y'all agree that I'm going to get 4 plus 6 minus what? 9. And I want to see if that's going to equal to what number? Negative 1. All right, we're almost done with this. What's 4 plus 6? 10. What's 10 minus 9? 1. So here's the question. Again, I'm going to have to go here. Is the square root of 1 equal to a negative 1? No, it's not. So, of those two proposed solutions, what's the only solution? T equals 0. The other one is what kind of solution? Extraneous. The other is extraneous solution. All right, so t equal 1, I'm going to go ahead and put that here. I'm running out of room with all this. So the solution, there's only one, and it's t equal 0. All right, so just go back and look at these notes again. Look at the video. It's not difficult. Just a lot of work, and notice that along the way you could have easily messed up, like when we had a binomial squared, but now you all know that a binomial squared is not a binomial. A binomial squared is a trinomial. Right? So FOIL it out. All right, we're going to do one more with this, and I think you should be okay. All right, so let's look at this now. Let's suppose I had this. So this would be number 7. You have the square root of x minus 5 plus 7 equal 2. Square root of x minus 5 plus 7 equal 2. All right, radical equation, we still perform those steps. That's 5. No, yeah, that's x minus 5. So What's the first step?
Isolate that.
Yeah, I isolate the radical, so what do I need to do?
Raise each side.
No,
Oh, I'm sorry. Subtract. So
subtract 7, right?
Yeah.
So I get the square root of x minus 5 equal what?
-5.
Negative 5. All right, so that's where I'm at. All right, let's just continue with the process. What's the next step?
Raise each side.
Raise both sides to what power?
Second.
Second power. And so I'm going to go ahead and just rewrite this over. So when I do that, the square and the square don't do each other, so what expression's left on the left?
X minus 5.
What's on the right?
25.
25. A negative 5 times a negative 5 is a positive 25. What's the next step? Add 5 to both sides. So notice in this case I went from a radical to what kind of equation? No, that's not quadratic. That's linear. All right, so you got to know the type of equations you're dealing with. So that's linear, right? So it's x. 30. All right, so that's my proposed solution. But I raised those sides to even power. So I could have introduced extraneous solutions. I could have introduced false solutions. But keep in mind that x equals 30 is a solution. It's definitely a solution to which one? The linear one, right?
Mm-hmm.
I just have to check and see if it's a solution to the radical. So where we see the variable x, what do I substitute? 30. So let's check x equal 30. So the square root of 30 minus 5 plus 7 equal 2.
Mm-hmm.
What's 30 minus 5?
25.
And what's the square root of 25? 5. Is 5 plus 7 equal to 2? No. So x equal 30 is not a solution. It's an extraneous root. It's an extraneous solution. But how many proposed solutions did I have? Just one. It doesn't work in the original. But I still have to answer what's the solutions. Remember what word we used? No.
Oh.
From previous course, remember what word we used when there aren't any solutions? No, you don't say prime. You just say no solution. You say no solution. I kind of gave it away. So there's no solution.
No real numbers.
So no solution. All right, so you say no solution. Now, in my math lab, they will use either the words no solution or they will use the symbol. What's the symbol? The empty set symbol. So remember, it looks like this. And it doesn't matter which one you use. Looks like that.
Mm-hmm.
Okay. All right. Now, one thing I gotta remind you. So when I came here, you see this right here? I just wanted you to see this. I'm gonna go ahead and rewrite this over. So notice this equation, when I isolate the radical, that number on the other side was a negative number, right?
Mm-hmm.
And so I'm looking at the square root right here. And this is a positive square root right here. Well, whatever I substitute for x, as long as it's in the domain, whatever I substitute for x, this number is always going to be what kind of number? Positive or negative or 0. It could be positive or 0. It's never going to be negative. So is a positive number ever equal to a negative? No. All right. So right away, when you see something like that, you would say no solution. So if you go back to numbers 2, look at number 2. I had to do the work in number 2 because if you go back to number 2, if you find it, you find mine. Okay. I have no idea what happened to it. Let's see. Okay, well, number 2, if you look at the square root, when you got the square root by itself, what kind of number was on the other side? Or what number was on the other side? Tell me the number.
64.
What?
He said tell you the number.
What's the number? 8? Okay, so 8 is what kind of number?
Oh.
Positive. All right, so that's why we did the work. Here we have the square root equals what kind of number? Negative. All right. Now be careful. If this had a variable in it, you still have to do the work. But as long as this is a constant, if it's negative, there's no solution. But students don't remember that, so just go ahead and do the work. Do the work, and you do what at the end?
Check it.
Check. Okay?
That's why
All
I
right.
like when you do each step.
Mm-hmm.
Do this
Yeah.
and over and over.
Yep. All
A
right.
million times.
So that takes care of that part of section 1.6. So this is 1.6. 1.6.